In this section, we're going to introduce something called function notation. In this chapter, there isn't any new math, but there is a new way to give directions using this notation. It will be very common for the rest of math, um, like for all of pre-calc and calculus. Most of the directions are going to be written in terms of function notation. Um, and so it's a little uncomfortable when you first kind of meet it, and then you get used to it, and it's not so terribly bad. Let's start with a few definitions. So, a function is a rule that associates each input with exactly one output, or in other words, for every x, there can only be one y. For every input value, it can only have one answer associated with it. So that's a definition of a function. Domain, I don't think we've seen domain yet this quarter. The domain is the set of the input values, so or the independent variable, or you can think of it as x if we're thinking in x's and y's. Domain is all the x's that you can put into a function. And then range is going to be the set of the output functions, or the dependent variable, or what we would think of usually as y. It's the set of all the outputs. And then last definition here is the vertical line test to determine if a graph represents a function, which we'll look at right down here. If any vertical line drawn would intersect the curve more than once, then the graph does not represent a function. So let's take a look at that. And I'm actually going to start on this one right here because it's not a function. If I draw a vertical line right there at 1, I hit the graph twice. So that would be no, based on the vertical line test. And if we think about it in terms of this definition, when x is 1, what's y? Well, y could be 1 or 2, so that's where there's more than one output associated with a given input, so that makes it not a function. This one, anywhere I drew a vertical line, I would only hit the graph once, so that one's a yes. This one's a no, because I can hit the graph 3 times, so no, not a function. And then that one would be a yes, because anywhere I draw a vertical line, I only hit it once. So same idea, but now it's a table instead of a graph. So for each input, so in this case x's and y's, for each input there can only be one output. So if we look at this, when x is 4, the output's 5, 8, it's 10, 15, it's 10. You might stumble on those 10s for a second and go, is that a function? And it is, because when x is 8, the only thing that y can be is 10. When x is 15, the only thing that y could be is 10. And what that actually would be, these two together would just look at a horizontal line. So a vertical line would only cross it once. So you can have repeats in the y values, but for each x you can only have that one output. So that is a yes. This one, everything is 4 gets you 5, 8 gets you 10, 15 gets you 12, so that's a yes. But down in this table, notice they have duplicates in x, so that means that's not going to be a function, because when x is 8, the output could be 10 or 12. And so that one would be a no, not a function. For 3 down here, switch over to black. This is asking us to give the domain and range of this relation. And so our domain is going to be the set of all of the x values. And usually when you're writing this out by hand, you write the numbers in order. I think for the computer, they're making it easy to type, so you can put them just in the order that they're presented. And notice I'm writing a brace here, not a very good one, but it's the parenthesis with the little pointy thing on it. When we're writing a set of numbers where it's going to be like a list, we use braces. I think on the homework the braces are around the answer box, so you don't have to type them. Anyhow, so the domain on this would just be the x values. And so that's all those. And then the range would be the outputs, the y values. And again, you don't have to order these for the homework. The next two are the same, find the domain and range, but this time based on a graph. And so looking at this graph, all of the x's would be the domain. So we'd have there, and there. So domain would be -3, -1, x is 0 for that one, and x is 4 for that one. So it's here, 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 and here, where all the places had x's. And then for the y's, we have there, 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 and there. So that will be our range. So it looks like -5, and then -4, 2, and 5. So this one's a little bit different in that it has graph in between the two dots, so it's continuous. So this is something we would indicate with interval notation that we saw earlier in the quarter. So our interval for which we would have where x is represented goes from -1 up to 2. And for the -1, we're going to use a bracket, because remember when we have a solid dot and we're including, we use a bracket. And on this side, we would have a 2, but it's going to be a parenthesis because of the open dot. And then our lowest point, so domain is left to right, range is low to high. So the lowest point on the graph, careful, it's easy to think it's 2 there, but it would actually be 0 because it's our y values are represented in terms of the y-axis right here. So that's all the places we have y values. This one's a whole, so we're going to be careful to use a parenthesis there. When x is 0, y is 4. That's just like another solid dot on that graph. So that's the interval that I have to indicate. So lowest value would be 0 with a parenthesis, and the highest value is 4, and that one would be a bracket because it's included. So that was a bit on sort of conceptually what a function is, and then domain and range of a function. And now we're actually heading into the notation. So the notation y equals f of x defines a function named f. So that's our function name is f. This reads y is a function of x, or f of x. And what the f of x is going to do is it's going to kind of substitute in on the y side of the equation. So instead of calling something y, we're going to say the output is a function of the input x. X represents the input, independent variable. F denotes the function rule, so if I had f of x equals x squared, x is the input, the function rule in this case would be to square the input, and that's going to make your output. So that's what that f is representing. And the letter y, or f of x, represents the output, or the dependent variable. So previous we had y equals x squared, and we will still see that for sure, but now we will also see f of x equals x squared. So we have a couple of things here. We have f of a value, and we have f of x equals a value. So, and I'm using a's here to denote the value. So f of a means to evaluate the function at a. So if this, say this is our function right there, and it's set f of 3, that means I am plugging 3 in for that x and I'm evaluating. If I have f of x equals a, so say I had f of x equaled 25, that means y equals 25. So when we have f of a number, that's the number is x. When we have f of x equals a number, that says, oops, y equals the x value, the number they're giving us is equal to the y. And so we're setting it on the y side of the equation, we're solving for x. So let's see that in a few different versions here. We'll get to this one actually in a couple of examples. So for this first one, we're given this function, and it doesn't have to be f, it's kind of the default, but it can be anything, and it's often G is the other one that you see all the time. So the function g of x is given. Here's our inputs and then here's our outputs. Evaluate g of 5. So that means that x is 5. So when x is 5, if we plug that in, what we get out is 1. So when we put in a 5, we get out a 1. This one is saying g of x equals 2. So the output equals 2, and we're solving for x. So what value of x produces an output of 2? So we come down here and go, there's our output of 2. So when x is 4, we get that output. Same thing, but with a graph instead of a table. Evaluate f of 4. So we come over here when x is 4, the output in that case is 2. And then f of x equals 4, that means that y equals 4, and we're being asked to solve for x. So where is y 4? Looks like right there is where y is 4, and so the x that makes that happen would be -1. And same thing, but now with an equation. So evaluate f of 4. Okay, so f of 4 means that all the x's in this equation are going to be replaced with a 4. We're evaluating it at 4. So f of 4 would be -8 minus 7, so that would be -15. So when I plug 4 into this equation, it produces an output of -15, is what this reads. Or when x is 4, the output is -15. This one, f of x equals -3, that's like saying y equals -3. So we're putting it on, replacing it for the f of x. And then we're just solving from there. So we'll add our 7 over. So adding 7 to both sides, we get 4 equals -2x, and then divide both sides by -2. And x equals -2. Same idea, but now we'll get some letters and a little bit more different things that we can evaluate at. So it doesn't have to just be a number. I'm going to do this one because I want to remind you how squares work with negative numbers. So if I'm finding p of -1 in this function up here, that means we're letting all the t's, in this case it's p of t, equal -1. So we'd have 7. Then right there, careful to get parentheses around those, and -1 times -1 is going to be a positive when we get there. 6 and a -1 minus 4. And so again, since we're squaring the negative, it's positive, so that would just be a 7, and then -6 and -4. So 7 minus 10 would be -3. So again, math we already know, but just a new notation to say what we're supposed to do. I'm going to write this one. I'm going to rewrite this here just so I can see it when I'm down below it. I can scroll down. So I'm supposed to find p of k. That is actually just a variable change. So everywhere there's a t, there would be a k now. So that would just look like 7k squared plus 6k and then minus 4. P of -t, so similar, but now we're going to evaluate it at the negative of the variable. So that would look like 7 and then -t quantity squared. So there's that negative we have to be careful with again. 6 times -t and minus 4. So a double negative would make that a positive. So 7t squared. This one would flip though, so that's 6 minus 6t and minus 4. And then for this one, we're evaluating p at t plus 1. So everywhere there's a t, now there's a t plus 1. So that's going to look like 7t plus 1 squared plus 6 t plus 1, and then minus 4. And we're going to expand this out so you can write it side by side and do the FOIL, and because this is t plus 1, t plus 1. And when you FOIL all that out or use special products, we'll have t squared plus 2t, because you'll get a t on the outside, t on the inside, and that'll add to 2t, and plus 1 plus 6t plus, careful to get that distributed, 6 minus 4. So that's going to be 7t squared. 7 times 2 is 14t. 7 times 1 makes 7. Plus 6t. 6 minus 4. I'll just put those together and make a 2 for a second. And I'll finish combining on this last line. So 7t squared. 14 and 6 is going to give us 20t. And then plus 7 and plus 2 should give us a plus 9. And then same basic thing, we're just evaluating the function. We're just doing it at sort of different expressions instead of just plain numbers. For this one, we're supposed to evaluate this function at 4b. Cool, so we'll go 3 and then 4b quantity squared plus 3 times 4b plus 2. And so 4b times 4b, which is what we're doing because it's squared, would be 16b squared. And then that'll be 12b plus 2. And 3 times 16, so that's 48. B squared plus 12b plus 2. And this last one, basically the same thing, just has a square in it. So it'll be 4 and then 3y squared, and this one is cubed, so all of that is replacing the x's. And 4 times 3y squared and plus 5. So 3 squared is going to give us a 27, and then y squared cubed is, I'm not sure if I just said 3 squared, 3 cubed would give us 27 if I said squared. Y squared cubed would give us y to the 6th. 4 times 3 would give us 12, y squared plus a 5. And then 4 times 27 should be 108, yes. Y to the 6th plus 12y squared and plus 5. So again, no new actual math, but just new ways to say, to give directions. And it's actually, like I said, it's going to show up pretty heavily in the rest of the math courses, so definitely something to make friends with.